The students who pursue this master are generally not just from the architecture background. They also belong to different kinds of streams, such as we had a couple of biologists last year who are now into some genetic architectural designs. We are also printing with cells, so that's an interesting part of design that you can explore with Rhino. So yeah, let's just begin right away. I'm also assuming that you guys either have the full version of Rhino or the trial version. Like right now on this machine, the computer, the laptop that I have right now, I am using the trial version of Rhino. As you would very easily notice, I have more than almost like 2.5 months remaining on this little license that I have. So Rhino allows you a 90-day license to use Rhino for all its purposes. Like you can have infinite amounts of saves and exports and everything. So it's a very easy way to learn the software, and in fact, you can also do some academic projects with it in 3 months' time. Also, Rhino is not that expensive for students and educators. So I think I think the price is around 100 to 150 euros if you want to buy it directly from McNeil and Associates, or maybe if you have a reseller that you know somewhere, you can probably buy it for a different deal as well. Maybe you can also have a Rhino lab license for your schools if you pursue them to take up this software and probably have it in your computer labs, which many universities, many institutions in India and abroad and everywhere in the world are pushing for right now. So because Rhino gives you these kind of different possibilities to do. Well, when Rhino had started as a modeling software, it was not primarily directed towards architecture students as such. And in a way, we have sort of hijacked this software for our purpose, and we have hacked it into getting molded to a software which is now primarily for architects. So something like Adobe Photoshop, which is just to correct your pictures and red eyes and adjust the blur or something, which is now used widely by architects across the world to make some stupid looking panels. So this software Rhino also shares a similar fate of being misused in a way, but now it's being morphed into something that architects use on a daily basis. So Rhino has a very, I would say, a mainstream kind of user interface like you would see in any other design modeling software. It has these 4 screens where you can visualize your model at the same time simultaneously. We have all the snaps here, which you might be aware of. The endpoint snap, the nearest point. A point is just for the object and the geometry that is a point. Then you have the midpoint, the center, intersection, perpendicular, tangent, quad, knots and vertices, which are specific to meshes, which are a different kind of geometry. And then you can, there are some enabling and disabling options, such as the project, which allows you to only draft in a certain plane. So those are the snaps. Then you have the options here where you can keep the orthogonal projections on if you want it to be planar, the object snap if you want it on or off, and then the more detailed options over here. The smart track, which helps you in object tracking basically, and the gumball, which is a relatively new feature to Rhino, and it allows modification tools in a very user intuitive kind of way. There is something called as record history, which is considered as the origin of Grasshopper, which lets you save points in your process of making a geometry, where you can go back to it, and it's similar to the history panel in your Photoshop screen or an Illustrator screen as such. There are certain filters, and then there is a changing dialog box which gives you dynamic information, such as how when you had saved it and such. We'll talk about these things more in detail when we use them for specific purposes. I'm just giving you a round off so that we are aware of what is where, kind of thing. There is a drop down menu here right next to each of these the views, where you can see what kind of view you're going to see your geometry in. We will see this also in more detail when we have geometry on our screens. As far as the ribbon on the right side goes, you would see that there are a lot of ribbons that are open here on my screen. Probably not all of them are open in yours. We will now do this, and now what we're going to have is all of us are going to have the same ribbons which are on, so that it's easier for us to communicate certain things and have a simultaneous approach to it. So make sure that you have clicked on the options, which is like a gear kind of a logo. It slightly gets highlighted when you hover on it. You just click on it and make sure that you have display is on. We don't need the help button. We need the layers. We don't need the libraries. Materials, we don't need them yet. Named views, yes. Notifications, no. Properties, yes. Not rendering. And yeah, and that's it. Yeah. Also make sure you have lights as on. So I'm just going to display the screen in front of you. So we have the display, the layers, lights, named views, and properties which are on. Okay. So mostly it is on the right side, but sometimes people also prefer to dock it up in the left so that they can use Grasshopper, but that's okay for now. So whatever is there is there. Yeah, I think these are the very ground basics, which I'm sure all of you are aware of. And I'm sure no one has any doubts so far. Yeah, no doubts yet? It's okay. You don't have to answer on the Q&A. I'm just assuming that you don't have any doubts. So if you have any doubts, you have 30 seconds to, Okay, so I'm just going to go ahead. Yeah, so the way we are going to start with these little tutorials is how we are going to very slowly graduate with different kinds of geometries that we can employ in Rhino. So we will start with something like, hey, how to make points, and then, oh, now that we have points, how do we connect those points, and then what are different ways to connect them, and then, oh wow, we have some curves now, and then what happens when you connect those curves, and then we have some surfaces and several ways to make those surfaces, to make surfaces from surfaces, and then so on and so forth. And then we go into mesh territory, where we see how to modify some meshes, how to edit meshes, and then how to extract points from surfaces, how to extract lines from surfaces, and several other modification tools that we are already aware of in different softwares, but we might see them being used in a slightly different way in Rhino. So that's how the whole structure is laid out. So today we will start with points and curves and a little bit about surfaces. And by the end of the day, by the end of the day, as in by the end of this session, we will have made a, a canopy for an architectural context. So like for a few building blocks, we would design and model a canopy in Rhino. And at the end, I will explain to you the challenge that you have to perform at the end of this session, and which you have to submit next week. The dates and all will be conveyed to you as well. So let's start with the points. It might seem slightly counterintuitive to make these points, but just go ahead with me and I will show you how this is very useful in dealing with clean geometry in Rhino. Okay, so I'm going to work mostly in the perspective view, but we will be using all of them from time to time. As you might already know, that if you double click on any of the names of the views, you get exclusive access to that particular view. And if you double click on it again, you go back to all the 4 of them. You can place it as you want. You can have more of this, more of that, but I prefer to keep it like this, but it's your choice how you want to do it. So I'm just going to double click on perspective, and now we're going to see how to plot points and multiple points and such. So there are several ways to input commands and put geometry into the Rhino canvas. The most easiest way is to type out the command, and you can see it on the command prompt with lots of options of what you can do with that certain geometry or that certain function or modification tool. Another easy way is also, like, as you practice more for the software, you would also like to use some of the buttons that are there around you, and most of the toolboxes have all the buttons, and you can customize them as you practice more and as you go ahead in the software. So this is the stock version of Rhino that we are using, and we all have the same thing with us. So I'm going to put just one point. Performing tasks and doing and making geometry in Rhino is very straightforward and highly intuitive, because the moment you type something, the moment you click on something, there will be instructions on the command prompt for you to follow. So I want to put a point, and for that reason I'm just going to left click on this little button here which says point. So okay, I left click on it, and the moment I clicked on it, now my command prompt says, hey, what's the location of the point object? So okay, fine, this is the location of the point object. I left clicked on it and the point is there. So I left clicked to select to put a single point, and then I left clicked again to show where the point needs to go, and the point is there. Now that I have put these 2 points, I can select one of them or the both of them, and we'll see some modification tools that can be used with them. Well, needless to say, zoom in, zoom out, and rotate, and you pan with shift and right click. So the moment I select this object, I have the gumball around it, and the gumball gives me different kinds of options that I can perform on this object to modify it to any certain way. As you can see, and as you might have noticed, that all 3D modeling softwares have a certain standard nomenclature. They follow a standard thumb rule to color code axis. So RGB, red, green, and blue, stand for X, Y, and Z, and you have them right in front of you. And this is common for all 3D modeling softwares. So as you can see, it has arrows in these 3 axes, so which means I can move by clicking on the arrow and dragging. So it moves in that particular axis, moves in this Y axis, and it moves in the Z axis or the Z axis. You can see it's being moved. So that's for move. But what if I want to move it with a specific amount, the specific amplitude? I just left click on it, and now there is a dialog box with a blinking cursor which says, okay, type away what you want to type. So I'm going to type something like 7, let's say, and I press enter, and it moves by the amount of 7 millimeters in this case. If I click on it again, it records the initial amount that I had put in. And now in this case, I can just press enter or just click. Okay. You would see other things as well displayed with it. So with the move, there is also a rotate. I mean, this doesn't make any sense because it's just a point in space, and it just has a location and no direction. So rotating is not going to do anything to that point. You're just going to see a point. But the concept of gumball holds true for any amount of selection. So like if I have one selection, it has the gumball around that object. But if I select 2 objects or multiple objects, the gumball stands right in the middle, the geometric center of those objects, and gives me all the modification tools. So now I can move both of these guys like so, and I can also rotate them like so. Also, I can rotate with a fixed amount, whatever that could be, or rotate in any axis that I want. You would have noticed that there are some small boxes over here with dotted lines. These are handles to scale something. Just like move, rotate, you can also scale it. And you have now scale in the x-axis. You can also scale in whatever axis you want. Like these points are now just points, so that's why the distance between them changes uniformly when you scale, but it would operate differently for different kinds of objects, which we are going to see in some time. So that's that. Now you can use the gumball to also perform an action while copying the object. So for example, if I want to move it, but I don't want to move it from its location, I want to copy it to a different location, I just have to press Alt and then copy. So when I press Alt, you would see a tiny little plus sign right next to my arrow, my pointer, and that's how you copy. You can also press Alt while rotating, and you can have this huge mess. Okay, so we have a huge mess of points, which I am going to just discard now. And how do you delete objects? You just select and press delete, or you just say delete and then you select, whichever way. Tomato, tomato. Okay, so now we have the blank screen with us, and now we know how to use the gumball to perform very basic modification tools on them, modifications on them. Now let's graduate to curves and polylines. So I'm gonna go and put some points on my canvas, but this time I'm not going to put single point individually. As you might have noticed, when you hover or when you just put your mouse pointer on the point button, it shows two things. It says, do you want a single point or multiple points? Now, single point, it has a little icon which looks similar to a mouse, and the left part is blacked out. So which means if you left click on it, you'll have a single point. Like it says location of point object. But if you right click, you can have multiple points. So I will just right click on my points button, and now I'm just going to put place points with my left click, left click, left click, left click. So I have now put 4 points. And after I'm done putting the points, it says you can press enter. So I press enter and I'm done putting points. So when you have to select multiple objects, select multiple locations to perform a function in Rhino, it will prompt you to press enter after you're done performing the function. The same logic also holds if you press space. So you can press space bar or enter, whatever you are comfortable with. So I have put 4 points now, and I'm just going to join them with a polyline. So I'm sure you guys know what a polyline is already. A polyline is a lot of lines. Poly, Greek for more than one. So I'm going to say polyline, and it says what's the start of the polyline. So I picked this point. Now before I do that, I'm going to make sure that some of my snaps are on, because the snaps are going to help me locate these points very precisely. How do I do that? I go down to my snaps and I make sure that the point object snap is on. By just clicking on it, it puts a tick and it now says that the point is on. But with the point, it also says the end point is on, the midpoint is on. I don't want that. I want the point to be on exclusively. Why? Simply. So how do I do that? To exclusively say that the point object should be snapped on, I right click on it. The moment I right click on it, the point is exclusively on and the others are switched off. So what it's going to help me with is my mouse pointer is going to be snapped to the point objects that are nearby. So now I'm going to say polyline again. And now it says, what's the start of the polyline? So yes, here I go and get snapped and snap and snap and snap. And when I'm done, it says press enter or spacebar. So here I have a polyline. Okay. I'm assuming that this is not rocket science to any one of you. And this is like, okay, show me the magic, Angad. This is basic. Anyways, so this is a polyline that we have made by connecting the 4 random points that we just put without any thought as such. Now that we have the polyline, let's see what different kind of properties this line has. So now, by saying that we have a polyline through 4 points, we have basically made 3 lines which are connected to each other at 2 points. Did you follow that? By connecting 4 points with a polyline, technically, we have made 3 lines that are connected to each other at 2 points. Okay, so this is the first point where they are connected, and this is the second point that they are connected. So two of them, 1 and 2, connected to each other at this point, and 2 and 3 are connected at this point. Okay, this is a very special case in what is called as geometric continuity. So I can say that this polyline is a continuous line. Okay, it is not broken, it is continuous, it follows a single thread, but the connection is just by the position of the points. Okay, so the x, y, z coordinates of the point at this edge is the same as the x, y, z coordinates of this point. And the same is true for this. Follow until this part? Okay. This is some of the core theory behind making curves and surfaces and lots of different magical things with Rhino and a lot of other softwares as well. So we have this particular polyline that we are so fascinated about, that it is a collection of 3 lines which is joined or connected and continuous at these 2 specific points. Now, this knowledge allows me to expand this polyline into several other possibilities. Let's see how. We are going to rebuild this geometry now directly into Rhino. Okay, so we have the polyline, and now we are going to type something that is rebuild. So I type rebuild. So select curves, blah blah blah, to rebuild. So basically it can rebuild anything. So we say yes, this is the guy we want to rebuild. We press OK. So it opens this nice little dialog box in front of us which says what exactly we want to rebuild. So as you see, there are several numbers and these 2 categories. The first category is point count, the points, the initial points that we spoke about. So the points were 4 and we have 4 in the small bracket. The number displayed in the small bracket, not the bracket actually, the parenthesis, is the number of points that exists, and the number displayed in the screen here is the number that we want. So it says 4, I'm just going to go back to 4. You can see that my display geometry changes with how I change things here because it's dynamically previewed. So first is the point count, which we know, okay, 1, 2, 3, 4. But the second one is something called as a degree. A degree is what we were speaking about when we said they are connected to each other by position. So there's just one parameter that connects them to each other, and that's the position, the coordinates. The XYZ coordinates are the same for those 2 points. So I'm going to get it back to something that was 1. So now you see how my geometry has slightly changed, not slightly, in fact drastically changed from what it was by just rebuilding it. If I crank it up to 2, it becomes slightly curved, and this point gets displaced to this. If I change it to 3, it gets slightly more smoother, and if I get it to 4, it ceases to appear. So we're going to keep it at nothing. We're just going to cancel it, and we will just copy to see different things that it will show by comparing them. So the first one is the one that I'm going to retain as is. The second one I'm going to rebuild and say maintain the same points but increase the degree to 2, and I hit OK. I say rebuild again, and I rebuild this guy to 3. Okay, and this curve is a smooth curve. This curve is also a smooth curve. This curve is also a smooth curve, but it has kinks. So kinks are these little points which are basically helping us control the geometry. I'm just selecting the points, just putting them across here. So the points, the polyline, and a curve with a degree of 2 and a curve with a degree of 3. Okay. So let's see some more things related to this. I have this curve, and the moment I select this curve, I mean without the points, okay, make sure that you don't have the points on it. Without the points, the polyline independently, just by itself, I select it and I see these points now on it. These points are called as control points, and their function is very simple. They control the geometry by just points. If you select these control points, you will see the gumball again, our little friend which helps us modify, and lo and behold, you can modify it dynamically however you want. However you want. Does this happen with the curve as well? Yes, of course. It also has control points, and those can also be controlled to move geometry around. And you might obviously have observed that it also has just 4 control points, the same number of points that we said it should have. You notice any difference in these two? You see, these control points are very close to the curve, but these ones, the one that has a degree of 2, has a control points which have a larger impact on it because they're so far apart. Okay, so we have these curves which came from points which actually were generated out of a mere polyline, and now they are being played with by some inhuman practices of control points. Okay, any doubts until this point? Okay, I didn't scroll down. What's the use of degree? The degree actually, what it does, as we saw here, if as you increase the degree, the geometry becomes smoother or more continuous at a higher degree. So for example, I will we'll talk about this again. So you have this little polyline, which if I rebuild again, it says by default it has 4 points and 1 degree. So it has a continuity of degree 1. Degree is like, let's assume that higher the degree, the more continuous it is. And there are different levels of continuity. So the first level is, as we said, so like degree 1 is basically continuity by position. So it's like, it's just going to be a polyline. As you have a higher degree, it's going to have, with position, you'll have the same radius of curvature. So basically it's going to be something like you're filleting two lines together. So if you have two lines and you fillet them, it's basically a fact that those lines are now having a continuity of degree 2. But degree 3 is when you have a continuity with the position, with the radius of curvature, and with tangency. So even the tangents are going to be same. You might have noticed sometimes that the designs that come out of, let's say, Zaha Hadid architects are curvy, but the curve is something different. You cannot just imitate the same curve in your design, even if you draft it. Even if you like take a section of it and you put it on your AutoCAD or whatever software you're using and you draft it, you can't really get the curve. The reason is because most of the curves, most of the continuity of the surfaces that, let's say, someone like Zaha, the company uses, are with a degree of 3, at least 3. Higher, like the next level, the next degree is 4, and degree 4 has the position, the curvature, the tangency, and also something called as acceleration. This degree 4 is mostly used by automobile designers. So when they are designing the surface of your whatever Honda or a Mercedes, they have to take care of aerodynamics as well. And the curves, the continuity that they use is at a more higher degree, which is they also factor in the acceleration, which you can obviously go like you can bring that as well in Rhino, because Rhino was basically made for industrial designers or designers who are dealing with surfaces a lot. So that's why you have this function, but you can use it in your surfaces if you want. But eventually, if you're going to construct it with bricks, your continuity is just, a series of chords, basically in plan. Does that somewhat answer your question, Sachin? Okay, let's go ahead. So this is basically the summary of continuity, geometric continuity, and we will keep bumping into it from time to time when we see continuity between surfaces, which is slightly more interesting than curves. But the continuity between curves is more evident, and you can understand it more easily over here. So moving on,